3, 4, 5, 6, 7. We totally understand.
Yes.
And can you name any odd number between 30 and 35?
31, 33, 35, 37, 39.
That's right. Even number between 17 and 22.
18, 20, 22.
That's good. Prime numbers. Do you understand what prime numbers are?
Prime number, yeah. Numbers that can't have any like multiples. Like no number, when you multiply them, gets to that prime number.
Uh, that is not multiple, that is factors.
Factors.
Uh, for example, do you agree 7 is a prime number?
Yes.
7 basically has multiples, that is 7, 1 times is 7, 14, 21, 28. These are multiples of 7. But 7 has only two unique factors. That is 1,
One
the
and
number itself.
one.
So if we have to discuss them, there are 2, 3, 5, 7, 11, and they continue. Definitely no number has an upper limit. So prime numbers are those which have two unique factors. What are square numbers?
Square numbers are basically numbers that you get from squaring a number. Like for example,
Squaring a
2
number
squared,
when
2 squared equals to 4. So 4 would be a square number.
that's right. When a number is multiplied with itself is
Mm.
a square number. For example, 13 times 13 is.
Sorry?
You memorize some of these? Have you memorized some of these?
No, I haven't.
Some of the square. Okay. Square of 5 would be
25,
25. Square of 7 would be
49.
correct. We will have calculator in each paper. So memorizing it is not the requirement. But
Okay.
always, if we know few of them, that would be quick. 13 square is 169. We'll ensure that we learn them till 15 at least. Then we have fractions, and fractions are of two types. One are proper fractions, other are improper. Proper is when the numerator is lesser than the denominator, and improper is numerator is greater than the denominator, and that could be changed into mixed number. No, mixed number are. Do you understand mixed number?
Yes,
So if we convert 12 by 5 in mixed numbers, what would it be?
it'd be 2 by 2 over 5.
Correct. 2 5 times is 10 and remainder of 2. So that is 2 by 5. So we can skip this. We already know what this is. We have already covered it in our previous years.
Mm-hmm.
Okay. Multiples and factors. We just discussed them. Fortunately, we discussed them earlier. If I talk about multiples of 3, name any first 4 multiples of 3. First is
3,
3. Second
6.
would
mm, Okay. 3, 6,
correct.
9, 12.
Very good. And if I ask about factors of 20, what would that be?
1, 2, 5, 10, and 4, and 20.
Correct. Okay, now I'll show you an easier method when you do that. It is always easy when we are actually writing them. So when we thought of 1, we knew that it is 1 times 3. Do you agree?
Sorry?
Directly, we are thinking of two numbers. When we thought of 1, we knew that 120 times is 20. So indirectly, we knew two of these factors. And when we were talking about 2, we knew it was 2 10 times. So that's how we think once and we get two answers. And then it was 5 4 times 20. And we got all of our factors. So we have no doubt in factors and multiples, which leads us to lowest common multiples and
Mhm.
highest common factors. Do you understand them?
Yes.
Okay, a quick concept. We are going to talk about HCF and LCM. Okay. For example, we have two numbers. We are in a debate and there are two teams, team A and team B. They have a match. Zubair says that A will win and Balam says that B team will win. Okay, now I have some coins which are worth $3 each. Balam has some coins which are worth $4 each. If we have to bet, what should it be? I place the first coin, Balam places the first coin. Is it fair?
No, because
It
mine is
has to be,
yeah, so we
yeah,
would both place down 12. So that would be 4 of 3
very,
coins and
very,
3 of 4 coins.
very good. So now we know that 12 is basically our least common multiple. And then if we want to make the bet interesting, that if team A or B will win it again, let's raise the bet. Now we know we have to make jumps of 12 each, right? So basically 12 is our lowest common multiple. And whenever we talk about this, this goes on. Where is this basically used? Now we have, let's say we have two buses. Bus A, it leaves every 3 minutes. And bus B, it leaves every 4 minutes. And they left at 9 a.m. When will the two buses leave together again? So LCM of 3 and 4 would be 3 1 times 4 is there. 2 1 2 2 1 1. 2 2 times is 4. 4 3 times is 12. LCM is 12. So we know that both of them will leave after 12 minutes. And the next time would be 9 12. Any confusion?
No.
Okay, one more thing. We have a racetrack. Let's say this is the racetrack and this is the starting point. One car completes the track in 7 minutes.
Mm-hmm.
Let's say that is car A, and car B completes the same track in 9 minutes. So basically at all times, car A leaves this track, car B leaves the starting point. We know that car A is faster than B, right? Because it takes less time.
Mm-hmm.
So what would be the time if race started at 10 a.m.? What would be the time when they both cross the start line at the same instant? Can you
This
do that?
okay.
We do have calculator at all times. I'm just keeping the numbers low, so we should accept it just by mental math.
So like you're asking me when there will
Race started at 10 a.m.
yeah,
and I need to know they're not stopping. They're just making those circles.
yeah.
And I need to know when will they cross the start line at same time again.
Oh, okay.
In the first 7 minutes, car A would have made that circle, but car B is still behind. It needs 2 minutes.
1103.
That's correct. So the LCM was 63 and
Mm-hmm.
63 minutes later is 11:03 a.m. Very good. Okay, now this was the concept of LCM. Before solving the question, we knew whatever the time would be, it would be more than 7 and 9. Any doubt? Whenever it is more than the numbers, it is lowest common multiple. And whenever we know that it would be lesser than those values, what we are thinking would be HCF. For example, we have a hall which measures 24 meters by 18 meters, and we plan to lay some tiles on it. And we wish that tiles are basically squared tiles. They're not rectangular, they're not circular, they are all square tiles. So what is the maximum possible size we could fit
Hmm.
and cover all?
Would it be 6?
That's correct. It would be 6. And we are basically looking at the HCF. So we'll have 4 6 meters on this side and 3 6 meters on the other side. And we are left with no space and all are squares. So this was the basic concept where LCM and HCF are used. Other than that, these are just numbers. During exam, now why did we do this exercise? During exam, if we face some questions like this straight away says find the LCM. So these are numbers for you and me. We don't know where they are used. They're just asking that find the LCM of 2 and 5. Do we agree that it is 10?
Mm-hmm.
For 3 and 9, do we agree that the LCM is 9?
Yes.
1, 3, and 7, do we agree that LCM is 21? Okay. Now we are going to the second exercise, which is how am I doing it without solving? I have not memorized them. So I'll show you. And the other part is whenever we have word problems, do you understand this thing? Word problems, statement
Mm-hmm.
questions, scenario, real life things. So those were the one. So we have to decide either it is LCM or HCF. Other than that, this is a very scoring topic. It is a straightforward question. And the examiner tells that find the LCM of 8 and 10. So we know this is 8, this is 10. This is prime factorization. 2 4 times, 2 5 times, 2 again. 2 times and 5 is not a multiple of 2. 2 1 time, 2 5 and 5 again. So this is 5 2 times 10. 10 2 times 20. 22 times is 40. So we know lowest common multiple for 8 and 10 is 40. And when we have those numbers, which are not multiples of each other, LCM is straight away that number. Let's have a quick rapid fire practice exercise. If I have some fractions, when I wish to add 1 by 2 and 1 by 3, I would write the LCM that is 6.
Mm-hmm.
And then what would I do? 6 divided by 2 is 3. 3, 1 times is 3. I'll write 3 there. Secondly, 6 divided by 3 is 2. 2, 1 times is 2. I'll write 2 there. And my final answer is 5 by 6. This is one of the methods students choose to do. Second would be 1 by 2 plus 1 by 3. What they do is they cross multiply. And what they write, 3 1 times is 3, 2 1 times is 2, and they multiply the denominators, which is 6 and 5 by 6. Method A, method B, and method C. That is 1 by 2 plus 1 by 3. They choose to write it this way. They write it times 3 times 3 times 2 times 2. 3 1 times is 3, 3 2 times is 6, 2 1 times is 2, 3 2 times is 6. And now we know the denominator is same and we just add the numerators and get 5 by 6. So either we follow method A or method B or method C, we always get the same answer. Which method do you prefer?
B.
Method B, okay. Now I'm adding a question and I would like you to use the same method and let's see if we get the same answer. This is 1 by 2 plus 1 by 3 plus 1 by 5. Okay, I prefer method A. I would prefer method A for small questions. For small values, method B is very good. So you do it with your method, I'll do it with my method, then we'll discuss. I'm done and I'm now checking it with the calculator for cross match. And calculator says that's right.
So 1 over 30 as a mixed
So
number.
do we have the same answer?
Yes.
Okay, now I'm following this method B as you prefer it. 1 by 2 plus 1 by 3 plus 1 by 5. How do you cross multiply it? Or do you first handle the 2 and then you introduce the third one?
Okay.
How did you do that?
I didn't use the B. Uh, I think I used like C for this one.
Okay. Even then, I'll just convince you with practice questions that method A is the best.
Okay.
I'll introduce those numbers that you'll agree to it. Yes, A is friendly at many times. Okay, if I do this with method B, this would be a little long. That is never incorrect, but a little long. It takes a little longer. So if we just cross multiply, this would be 3 plus 2 by 6, and we are leaving 1 by 5 for later. So this becomes 3 plus 2, that is 5 by 6 plus 1 by 5. And again, we cross multiply. 5 5 times is 25. 6 1 times is 6. And 6 5 times is 30. And this is 31 by 30. We do get the same answers. Logic is true for all. Math is correct for all. But we have to prefer that method. One, it should make sense. The other is we should save our time for longer questions. And why I'm preferring that is when we have these type of questions. For example, 1 by x minus 3x plus 2 over x square. Now we actually don't know what this number is. Or suppose we have x plus 1. And then method A will work for every statement. Okay? We'll learn this shortly. We'll learn this shortly.
Okay.
Okay, now let's start. Now, what am I interested in? Just the LCM, not the complete question. Okay? When I write 1 by 2 plus 1 by 3. I just need to know the LCM. And what is that?
6.
Correct. 1 by 2, 1 by 5. LCM is
10.
correct. 1 by 2, 1 by 7. LCM is
14.
correct. 1 by 2 and 1 by 4. LCM is
2, 4.
4. Correct. 1 by 5, 1 by 10.
LCM is 10.
Correct. 1 by 6, 1 by 9.
LCM is 18.
Correct. So when the numbers are not factors of each other or not the multiples of each other, we just multiply them to get LCM. 2 5 times is 10, 2 7 times is 14, and so on. And we know when they are in the same table, the larger number is the LCM. So 1 by 2 and 1 by 8, what would be the LCM?
1 by 2 and 1 by 8.
Yeah,
8.
correct. 1 by 2, 1 by 20, LCM.
20.
20. 1 by 2 and 1 by 10,000, LCM.
10,000.
10,000. So we are very clear what the LCM is.
Yes.
Now, basically, 2 was 5,000 times. So these are the simple steps. What we do is 1 by 2 plus 1 by 3. LCM is 6. So we don't have any issue finding the LCM.
No.
And now, these are the steps. Divide, then multiply, and then write the answer. So 1 by 2 plus 1 by 3, this is 6. 6 divided by 2 is
3.
3. 3 1 times is
3.
3. On the other side, 6 divided by 3 is
2.
2. 2 1 times is
2.
2. So that's it. Question complete. Now let's try this question again. 1 by 2, 1 by 3, and 1 by 5. 1 by 2, 1 by 3, and 1 by 5. If we do not know what the LCM is orally, what we could do is we can always go for prime factorization. This is 2 1 times, 3 and 5. Then we have 3. We always start off with the smaller number. Then we have 5. And we know that 5 3 times is 15. 15 2 times is 30. Any objection that the LCM is 30?
No.
Okay. Very good. 30 divided by 2 is
15.
15. 15 1 times is 15. Seconds. 30 is
Sorry?
30 by 3 is
10.
10. 10 1 times is 10.
10.
And the sign comes in between them. Last one. 30 divided by 5 is
6.
and 6 1
6.
times is last step at 15 plus 10 is 50 plus 31 by 30. Complete. Getting it?
Mm-hmm. You're just
Okay, now
freezing.
look,
Sorry,
let's
sometimes.
have a look. Okay. Well, I was just switching between two documents. Okay. Do we have any about the factors?
Hmm?
Factors of 12 are 1, 2, 3, 4, 6, and 12. Any kind of issue in this
No.
factor thing?
No.
Very good. LCM of given numbers. Any issue in finding the LCM?
No.
What if we have a question that what is smallest and largest vector? For example, we are talking about 100. What would be the smallest vector?
Sorry, what? Sorry. 100?
Smallest vector of 100. Yeah,
1.
correct. And the largest vector,
50.
what about 100 itself?
Oh, yeah. 100 itself, yeah.
Oh, yeah. Okay. And when we talk about the same number, and I say, what is the least multiple?
Lowest multiple
Smallest multiple of 100.
is 100.
Correct. And what would be the that's think before you answer?
Sorry? The largest multiple? It can be anything. It can go on infinitely.
Yeah. Correct. So we cannot answer it. We would say no solution
Okay.
because we don't have any upper limit. So that's a trick question, and we don't have any such question examination. Okay, so we have these pairs. I'm just moving forward because you give me that confidence that you know them, and we can spend some time on the next topics. So we know how do we have to find the HCM. Just to be sure, can we just practice these first two, A and B?
Okay.
Can you quickly do them? Thank you.
3 for A.
Correct. Correct for A.
Mm-hmm.
And for B,
For B. 8.
very good. So we are clear on HCF. We are clear on LCM. We are clear on what factors are, and we are clear on multiples. Before that, we discussed odd numbers, even numbers, prime numbers. So we don't have any issue in these 6 subtopics. Okay, moving on, moving on. These are just the methods. If you can see the screen, to
Mm-hmm.
finding the LCM of 36, either we write it this way, 36 by 2 is 18, by 2 is 9, that is 3, and 3 again. So we know it is a product of 2 times 2 times 3 times 3. And we can write it as 2 into 2 into 3 into 3. And we do get the same answer. So these are just the different methods of displaying, known as prime factorization. HCF, for example, prime factorization, LCM. Okay. Divisibility test is basically when it leaves no remainder, we know that a particular number is given divisible by a particular given number. For example, we have this 60 by 5. The rules are basically not asked in exam as we have to keep 60 by 5. If there is no remainder, yes, it is multiple of 5. Let's see 1, 2, 3, 4, 5, 6. It is divisible by 9. And I'm getting a decimal number. So that's a no. It is not a multiple of 9.
Okay.
Okay, power and roots. This is not basically truly indices. Some concepts of that will do indices in details. So you understand what 2
Yes.
cube is and what would be 4 square.
16.
Okay, 4 cubed.
64.
Very good. And if I do the reverse, that is square root or cube root, 125 cube root. Do we know the answer?
125. 15.
That is 5. I'm
No.
coming back. We do it.
Oh, cube root.
Oh,
And
cube
15
root.
wouldn't work anyways, would it? Okay.
I'll show you how we do it. If the examiner says that show all your working, although we agree that calculator is allowed in P2 and P4 both, but
Mm-hmm.
when the examiner says that show all your working, then we should know how we should do it. For example, we had this question and we do not know what it was. We always go for prime factorization. This is 5 25 times, 5 5 times, and 5 1 time. So I would know that I have to write 5 cube and I could cancel these and my answer is 5. For example, let's have a basic question which we know what the answer is already before solving. We know that square root 64 is 8. We know that cube root of 64 is 4. Any doubt?
No.
But let's assume we don't know that. So how will we solve it? Once we go for prime factorization, this is 64. When I divide it with 2, that is 32. 2 again, 16. 2 again, 8. 2 again, 4. 2 again, 2. 2 again, 1. That leaves me a count of 1, 2, 3, 4, 5, 6. So what am I going to do is 1, 2, 3, 4, 5, 6. When we are dealing with root, when we are dealing with square root, we make pairs of 2 and this. So I can write 2 squared times 2 squared times 2 squared. Then I can take the power common, 2 into 2 into 2, and take square as common. Now I can get rid of these two, this root and this square. So I'm left with 8. The other side, I could directly make pair of 3. And I can write 2 cube times 2 cube whole cube root, which is 2 times 2, part 3 cube root. And we can get rid of these two and I'm left with 4. Any confusion? So whenever the number is large enough, this is the
Mm-hmm.
method we use. Or if we have not memorized it. For example, number is cube root 3375. I'm sure no one would have memorized it. So how will we go about it? That is 3375. So let's try. 3375. That surely does not go with 2 because that's an odd number.
With
If we
5?
try it with 3, I get, yeah, that is possible with 5. We always try to start off with the smaller number.
Okay.
There's no issue at all, even if you started with 5. That's a general practice.
Okay.
Okay, this is what I get. So my number was 3375, 3375 cube root. This cube allows me to make pairs of 3. That is 3 cube times 5 cube whole cube root and 3 5 times whole cube root, eliminating the root, and we got 15. So basically 3375 is 15 cube.
Hmm.
Or the other round, cube root of 3375 is 15. Now, this practice would allow us to write numbers. Have you ever gone through those questions when the examiner says, leave your answer in exact form, like avoid decimals? For example, we are going for area of circle,
Mm-hmm.
and if the radius is 7, I'll write pi 7 squared and write 49 pi centimeter squared. And I will not write the value of pi to avoid decimals, to give answer in exact form. So when they ask you to write square root 18, this is now how we know. And we know that 18 is not a perfect square. So 2, 9 times 3, 3 times 3, 1 time. So that is 3 times 2. Now 3 can get that freedom. How? This is how. We get rid of this root. This is 3 square root. Basically, square
Nice.
root 18 could be written as 3 square root. Got the idea?
Wait, how can 3 square root be
Okay.
written as 3? Oh wait, yeah, it just cancels
3 square
out.
root 2 could be written.
Yeah, it cancels out with the square and the
Yeah.
yeah, okay.
Let's have one more question to avoid any sort of confusion. Square root 24. Is it a perfect number?
No,
Is it a perfect square?
no.
So we go for our prime factorization. 2 12 times, 2 6 times, 2 3 times, 3 1 time. So do we agree that we have only one of the pair? So may I write it like this? May I display it like this for square root 24?
Yes.
We're getting rid of this. This is 2 square root 6.
But
Like, quickly make use of your machine and see, do you get the same answer? Do you have it with you currently, calculator?
I don't have a calculator with me right now.
No, no issues, no issues. Uh, you can practice it later. This is just to be sure to be confident.
Okay.
And why are we doing this? When the question says, show all your working, this is how we do. Okay. So this is actually going far better than I expected. Your mental math is good. Okay, now the visual representation. What square means, that is two-dimensional. What cube means, that is three-dimensional. Or the number is multiplied with itself 3 times or 2 times, and so on. This was square of 169. And how do we find square root of 324?
Hmm?
Finding the square root of 324.
We try to find the prime factors of it first, and then we find the pairs of it
Correct.
afterwards, and then we just
Very good.
do the equations.
Very good. Give it a try.
Mm. 2 times 18? No, I think I did something wrong. 2, 324.
That's correct. 18 is the correct answer.
Okay.
So now it never matters whatever the number is, as far as we know how to go for prime factorization. Then we can make numbers.
Wait, for
So
the
I'm
prime factorization part, for like after 162,
to
it would be 3
same
with
step,
81?
factorization, getting rid of power decline. 81 is an odd. As 81 is odd, it would go with 3.
Sorry, can you repeat that? You froze for a second. I can't hear you.
Can you hear me now?
Yeah, I can hear you now. Wait, could you clarify the part about 3 and 81 again? Because I wasn't able to hear you last time.
3 is an odd number. So it is not divisible by 2.
So we just put it next to 3. Okay.
3 27 times is 81. Okay. Can you see this page?
Yes.
I will share this as practice exercise. How to do set random questions.
Okay.
Okay. For example, we have question 1, any 2 parts. Question 2, any 2 parts. I will also share answers with you. So in the next class, we exactly know what we need to discuss. We may get all the answers correct. We may have anything to discuss. Is it fair?
Mm-hmm.
Okay, let's get it. Should be exercise soon. Okay, now use of symbols. Copy the numbers and fill in less than or greater than. This is the concept of number line. And this is very interesting exercise when it gets negative numbers. May I say to you is in this first question 1, A part, may I say less than 8?
Sorry?
you understand what less than or greater than
Could you repeat the question? I couldn't
less
hear
than
you.
is that? Yeah. I'm asking if you know these signs less than and greater.
Yes, I do.
Less than. Okay. Do you agree that this question one is done correctly?
Exercise 1.12 question.
Yeah. Can you just switch off the cameras for some time? Signals are unstable.
Okay.
Okay. So what would it be in B part?
Oh,
Is
okay.
this correct?
Exercise 1.13. Okay.
Is this correct? Is B correct?
No.
So what about K part? Minus
What
12 is
means
less than minus 4 or greater than minus 4?
is less than minus -4.
Is less than. Correct. So what about arrangements? Can you arrange them
Yes.
in ascending order?
Mm-hmm. So would it be -12, -8,
Correct.
-1,
Very
7,
good.
then 10?
Very good. Very good. Okay. Now these are simple reading skills.
Mm-hmm.
Study the temperature graph carefully. There are two things which with the exam point of view. One is we should understand what the trend is. So generally, I would say that the temperature first falls and then keeps rising. So it has
Mm,
basically a dual trend. It is falling and it is rising.
yes.
In comparison, if I would have few scattered points like this, I would say generally it is increasing. And if I had to draw a line of best fit, this is what I would do. Any doubts?
Mm,
So
it is
how
increasing, just a
we
straight line going
read?
up.
Very good.
Okay.
That's it. That is it. So we say that the trend is positive because x-axis and y-axis both are increasing.
Okay.
So question number A, what was the temperature on Sunday 14th? Can you do that? Do you want me to zoom in?
Yes.
Temperature on Sunday 14th.
Um, it was
Correct.
1?
That's right. Correct.
Okay.
1 degree Celsius. By how much did the temperature drop from Sunday 14th to Monday 15th?
It dropped by 1.
Very good. What was the lowest temperature recorded?
The lowest temperature recorded was uh -3.
Very good. What is the difference between the highest and lowest temperatures? Uh, can you see the complete graph?
Yes.
Okay. So difference between highest and lowest temperature.
It was 12 degrees.
Very good. Larger number minus the smaller number and the difference is 12. degrees. Okay, word problems. Question number 4. Matt has a bank balance of $45.5. He deposits $15 and then withdraws 32. What is his new balance?
Deposit means he adds, right?
Correct.
Okay. $28.5.
Very good. Very good. So do you understand how to handle statement questions?
Yes.
Try question number 6.
Wait, so I like okay. -11? The deficit -11?
Correct. Either we can say -11 or we can just write the statement. It is 11 meters below the
Below.
surface.
Okay.
That's correct. Are you reading it?
Hmm?
I thought you were reading it. I was moving on the next page.
No, no, no.
Okay. Order of operations. Do you understand word mass? What
Yes.
word mass means?
Mm-hmm.
Very good. So we can still save our time and just jump to the practice question. So if I write 6 plus 2 divided by 2, what would be the answer?
It would be 7.
Very good. Okay, let's try some harder questions. When brackets are there, we have no issues.
Yes. No issues.
What is the answer to this I part? Part L, last part.
It would be 0.
Very good. And H,
H would be 3.
see that again.
14. And then 19 minus 14. Oh, no, no, no. 5. 5.
Okay, okay, good. So sometimes questions are easy.
Mm-hmm.
We just have to, or I may call that an elementary mistake. Okay. Question 2, H part.
Oh, 1.
Very good. Okay, let's try this. Read it carefully. I part. Make sure we don't make any copying mistake. Can you see the brackets clearly?
Yes. 868.
You said 300?
I said 868.
That's correct. 868. Very good. Is it possible that you can share a few books which you are already using so I can gauge the difficulty level?
Okay. Well, my school books, right? The books I use in school.
Yeah.
I'm using the Cambridge book, so basically, I'm using the Cambridge Checkpoint Mathematics 9, Stage 9
Share,
books.
share anything like the PDF or picture, anything later. No issues.
Okay.
Okay. Try this A part when there are no brackets.
53.
Very good. E part.
37.
Correct. F part.
Mm, 36.
Let me see. This is 6 times 2 divided by, that is 3 plus 3 is 6. So I can write 6 times 2 into 1 by 6. So that is 2.
Okay. Okay, yeah.
Okay. Do you understand? We can
Yeah.
take reciprocal when we convert from division to multiplication.
Mm-hmm.
Very good. Okay. Let's choose O part.
6.
Good. H part.
4.
Very good. I part.
4.
Very good. E part.
3.
Very good. Okay. Do you know what this statement means? State whether the following are true or false.
Yes.
So how would we do? We'll solve both sides and see if it is true or not. Let's try this D part.
Okay. Mhm. Yes, it's true.
Okay, this was 101 and that is 11. So it's true. Okay. Place the given numbers in order in the correct spaces to make correct number sentence. So if we have to use this, we could go for hit and trial as well. And we place these three numbers here and any fourth number on the right side. So give it a try.
Uh, 5 minus 2 divided by 10.
5 minus 2 by 10.
And
And last
3
one should be 0.
0. Yeah.
I think this is not in the right order.
Hmm.
You see, if we solve this, this would be 5 minus 1 by 5.
Okay.
If you write these numbers, this would be 5 minus 1 by 5. So it has to be other way around. If I have to make it 0, can I just switch these two?
Yeah.
So 5, 10, and 2. So 10 by 2 is 5. 5 minus 5, that is 0, equals 0. Okay, let's try one more for today. D part. 4, 5, 6, 9, 12.
Fourth. Oh, okay. 4 plus 5, and then subtracted by 12 minus 9. I mean 9 minus 12.
Okay, let's see. 4 plus 5 is 9, and 9 minus 12 is minus 3. So this would be 12, and it is not equal to 6.
Okay.
I think this one is a healthy practice. You have to think about numbers. Do you want me to do it?
No, I'll try for a second more. Can you show me this one?
Yes. Luckily, the numbers are all in order already. That is 4, 5, 6, and 9, then 12.
Hmm.
Now, 4 plus 5 would be 9, minus 6 minus 9 is minus 3. Minus minus is plus 3. So 12 equals 12.
Okay.
Right?
Mm-hmm.
So let's have a quick overview. What we did was with the topic 1. I was expecting 2 to 3 classes, but I think we've wrapped up this in one class. Numbers, odd number, even number, integers, prime numbers, squares, fractions. We talked about LCM, HCF, multiples, and factors. And definitely I'll share a practice exercise. And you don't have to go through all of them. Select it random. I will also share the answers so that you would know which questions you're getting right. If there is any confusion, we'll definitely discuss in next class.
Okay.
Okay, then we discuss prime numbers, squares, roots, and then few symbol questions. And here we are. These are simple statements. We should have like an idea of this. A profit of $100, that means a positive value. And when it says above sea level, again, positive value. Below sea level is a negative value. Either we minus 25 kilometers is the displacement, or we just give the word below. Reading of graphs, operations, BODMAS. Okay, so unit 1 is complete, and this was a far better class than other students. Keep it up.
And then
We'll
next
inshallah
algebra.
go to chapter 2 in the next class. After